physics, and we'll continue with light energy about what we have learned last time. So we'll start with what we learned. Okay, in the last class, since I did some of the things on the board and I might not be, I'm not sure that you might have understood it quite well on the board, so I'm revising it once. So let's start with refraction. What is refraction? Refraction is the transfer of light from one medium to another. So this is how refraction takes place. Okay, when you transfer the light which passes from one medium to another, what happens? It changes its path. Okay, either it slows down its speed or it increases its speed. So refraction is the bending of light as it travels from one medium to another. So what is refraction? Is the phenomenon in which light bends when it passes from one medium to another. Now this is how what refraction would look like. When light passes from one medium to another, as we said, it bends. The light bends. Now depending upon the medium, how it transfers. When the light transfers from rarer medium to denser medium. So I told you what is rarer medium. Rarer medium means the particles are more apart, and denser means the particles are more close. So when the light passes from a rarer to a denser medium, what happens? Its speed decreases, and when its speed decreases, the refracted light move towards the normal. So this straight line is your normal. Okay, this straight line is your normal. The dotted line is your normal. This is your incident ray. When it falls from rarer to denser, its light speed decreases and it moves closer towards the normal. Okay, just the reverse. When the ray of light passes from denser to rarer, its speed increases and the refracted ray moves away from the normal. Okay, don't be confused with this dotted line. Just see this part. This is your normal. This is your incident ray. This is your refracted ray. So what is happening over here? The refracted ray is moving away from the normal because the speed increases. And what happens over here? What happens over here? The incident ray, this is your normal. Instead of going straight, it bends towards the normal. Okay, so this is what happens when rarer to denser and denser to rarer. And what happens when a ray of light is normal, that is, makes an angle of 90 degrees to the surface of another medium. So as we discussed this, it passes undeviated. That means the incident ray and the refracted ray will be on the same line. The normal, the incident ray and the refracted ray, they all lie on the same line, straight line. Okay, so these are the three cases. Now this is how exactly a refraction would take place. The light which falls on the surface, a light which comes from the source and then falls on the surface is called incident ray. After striking on the surface and passing through another medium, when it enters another medium, it's called refracted ray. The straight line, imaginary line, which divides the incident ray and the refracted ray, or between the incident ray and the refracted ray, is called normal. Okay, now the angle formed, this is the angle formed between the incident ray and the normal is called angle of incidence, represented by small I. The angle formed between the normal and the refracted ray. Okay, this angle formed between the refracted ray and the normal is called angle of refraction, represented with small r. Now, we'll be discussing about the laws of refraction. There are two laws of refraction. Just like laws of reflection, there are two laws of reflection, same way there are two laws of refraction. The first law will be the same for reflection as well as refraction, which means the incident ray, the refracted ray and the normal at the point of incidence all lie on the same plane, which means this incident ray, the refracted ray, the normal, the angle of incidence, angle of refraction, they lie on the same plane. So this is your plane. Okay, what is a plane? Plane is any flat surface. So it lies on the same flat surface. Okay, so when it lies on the same flat surface, so this is your first law of refraction. The incident ray, the refracted ray, the normal, the angle of incidence, angle of refraction, they all lie on the same plane. Okay, the second one is for two given media, that means two given mediums. Okay, media is a plural of medium. For two given media, the ratio of the angles, when you take the ratio of the angle of incidence and the angle of refraction, is all constant. Now this sign that we write over here is a trigonometric ratio which you'll be doing in class 9. Okay, as of now just understand it's just a mathematical, it's a trigonometric term. You just need to understand that if you take the ratio of the two angles, that is angle of incidence and angle of refraction, what will you get? The answer will be a constant. Constant means a fixed value. Okay, so will be a constant. Where I is the angle of incidence and R is the angle of refraction. And the second law of refraction is called Snell's law, not the insect snail. Okay, it's the name of the scientist. SNELL, snail. Not SNAIL, snail. Okay, it's SNELL, snails. Only the second law, not the first law. Only the second law is called Snell's law. Now see here, Snell's law. I'm just elaborating it a little bit, not much. In 1620, Willy Snell, the Dutch scientist, discovered the link between the two angles. Their signs are always in proportion. So why is the second law in particular called Snell's law? Because it was the Dutch scientist Snell who found the link between the two angles. And the two angles are angle of incidence and angle of refraction. Okay, and they are always in proportion. That means they are always in a correct proportion. So when light passes from one medium into another, the sign of angle I and the sign of angle R will be a constant. And that constant is called refractive index. Okay, what is that constant? That constant is called refractive index. Okay, so I hope this is clear. The second law states that the sign of angle of incidence and the sign of angle of refraction bears a constant. That is a constant. That means when you find the ratio of angle of incidence and angle of refraction, what do you find? The answer to be a constant. And that constant is called refractive index, which you will be learning more in your higher classes. Here in class 8, you just need to understand this, and you need to understand that the second law of refraction is called Snell's law because it was the Dutch scientist Snell who discovered the relation between the angle of incidence and the angle of refraction. Now we'll be learning about effects of refraction. Okay, we'll just be learning, not much. We'll just learn half of the effects of refraction. Now you might have seen. When you see a swimming pool, when you go to a swimming pool, when you see it from outside, what do you see? It doesn't seem that deep, isn't it? But as you enter the pool, it seems deeper than you actually thought, right? The same way, when a coin is placed in a vessel or a cup filled with water, it seems to be a little bit up. But when you put your hand inside the cup, it seems to be deeper than it actually is, isn't it? So these are the effects of refraction. All this happens because of refraction. It kind of creates an illusion for us. Okay. So we'll be discussing how does it create those kind of illusion for us. The refraction causes visual effects such as ruler appearing to be bent. So when you put a ruler in a transparent glass, when you put a ruler and when you see it from outside, what do you see? It seems to be bent, isn't it? The ruler seems to be bent, but actually it's straight only. It's not actually bent, but looks like it's bent, isn't it? It's because of refraction. This happens because light from the path of the ruler in the water is refracted as it travels from the water into the air. Now see, this is your ruler. Now what happens is, when a ray of light comes from a source and then passes from this medium, air, to water, it bends. Okay, it bends, and as it bends and it hits the ruler, it reflects back. Now when it goes back, when it's going back, say if it's going back, this is passing from water to air, which means the ray is passing from denser to rarer medium. So when it passes from denser to rarer medium, the light bends away. Okay, the light bends away because what happens? The speed increases, the light bends away. Now when the light bends away, it deviates from its actual path. So an observer which sees from outside will be seeing it a little bit risen above. Okay, it sees that the level of the ruler has come from here. It has come from here. But actually the level of the ruler is, the tip of the ruler is here. Okay, the same way. When you keep a stone or the depth of the water, as we said, seems to be a little bit, when you put a stone in a water or a coin in a water, so when you see it from outside, what do you see? You see the coin to be lifted up, isn't it? You don't see the actual depth. You see it to be a little bit lifted up. Now why does it happen? The same way, a ray of light passes from here, okay, passes from here and then enters. Now when it enters and strikes this stone, now it reflects back. When it reflects back, it goes from here. Okay, it goes from here. Now it's passing from denser to rarer. When it passes from denser to rarer, the light bends more. When the light bends more, so what happens is the light bends more, and the person who is seeing from here will be seeing this straight line. Okay, for him, what happens is he sees to be a straight line. And it seems that this stone appears to be here. Okay, so it seems to be a little bit up. So this is what actually refraction does. That is, kind of creates a visual effect, kind of creates an illusion for us. Okay, light rays from the stone are refracted as they leave the water. The brain assumes that these rays have traveled in straight lines and is fooled into forming an image where it thinks the light rays came from. So it's just a kind of illusion that it's created in our mind because of the refraction of light. Okay, so some of the examples. The straw appears to be bent in the liquid. Again, the same way, when you put a straw in a liquid, what happens? It seems to be bent. The same reason, the light which is refracted from this straw, okay, it moves from denser to rarer and bends away. Now when it bends away, the straight, it seems to be, say this is your light which is refracted from here and it goes till here. Now it bends away from here. Okay, it bends away. Now the person who is seeing from there will be seeing the straw to be somewhere here, the tip of the straw to be here, and that's why it looks bent. As the light crosses the boundary between the fluid and the glass, it is bent, producing a distorted image. Okay, so this is known as refraction. The same way, a fisherman who is using a spear fishing has been used for centuries and still practiced by subsistence communities. To accurately spear the fish, fishermen learn to aim a short distance behind the fish's image in order to compensate for the effect of refraction. So if you are not a pro and if you don't know how to fish, but if you are fishing with a spear, the illusion created by the refraction of light, what happens is this is the actual fish. It seems like the image is somewhere here, and you will be trying to kill the fish. You will be trying to catch the image of the fish. So if you are a pro, you will know exactly. You need to aim it a little bit behind the image so that you get the actual fish. Now refraction in a pool, the same way as I told you, the depth of the pool doesn't seem to be that deep when you see it from outside, and that's why they always always mention the depth of the swimming pool, isn't it? Why? Because it's actually deeper than we actually see it. And why is it so? Again, here it is the effect of refraction. The depth of the swimming pool, it seems to be lifted up. Why? Because the light which passes from, refracts back from this depth, okay, it will be bent. As it passes from water to air, it bends away. Now a person who is seeing from here, he seems to see it straight. And then, it seems to be seen somewhere else, a little bit lifted up. So you might have stood by a pool and seen an object at the bottom that you want to pick up. When you dive into the object, it wasn't there, it appeared to be. So this is what it happens during refraction. We'll be discussing this advanced sunrise and delayed sunset in the next class. So I hope you understood what is being taught today. If there's any doubt, please do call me. Okay? Thank you and have a good day.